We know what 30, 60, 90 triangles look like and what their side lengths are. It looks like this is a 60-degree angle that is created. Okay, well, watch me just throw a line coming down from the 60 degrees to create a triangle. Not the time to freeze. Notes. It's just upsetting when this happens. There we go. All right, here we go. If I throw a line straight down, I could say, oh, that's 60 degrees. That's 30 degrees. What's the longer side in a 30, 60, 90 triangle? Root 3 over 2. What's the shorter side in a 30, 60, 90 triangle? 1/2. We have that memorized, so it's easy if you have a quiz question like that. Right? I could throw a line going down like this, and if this was 30 degrees, I'd say, oh, okay, this is my shorter side, this is my longer side, with the hypotenuse of 1. Good with that? Right? It's just throwing a triangle inside a circle. Okay. We can throw these triangles in other locations, though. Right here, I could throw a line right here, and I could say, okay, well, this is 60 degrees. This must be the longer side, root 3 over 2. This must be the shorter side, 1/2. However, we're kind of in an XY plane. And I'm kind of going left and down. My X's are negative when they're to the left. My Y's are negative when I go down. Does that make sense? So I'm just going to just list this side as -1/2, and this is negative root 3 over 2. I'll do the same thing with this angle. I'll throw a line going up. And I'll say, oh, if this is 30 degrees, great. The opposite side is going to be the shorter side. This is going to be the longer side. Now I'm going to the right. X is to the right. That's a positive direction, right? I'm going down. I'm going to say that's the negative 1/2. I could throw an angle right here. Well, this would be a 30-degree angle. This would be the smaller side. This would be the longer side. This side length would be root 3 over 2. But since I'm going to the left, I'll say it's negative root 3 over 2. Okay. We can do the same thing with the 45, 45, 90 triangle. This angle right here. I could throw a line coming down. I make a triangle. 45, 45, 90. Well, that means this side would be root 2 over 2. This side would be root 2 over 2. And this side would be 1. However, I'm going to the left on an x-axis. So that's going to be negative. I'm going up on the y-axis. So that's positive. So that's good. Maybe right here. Well, if this is 1 and it's a 45-degree angle, this would be root 2 over 2, and this would be root 2 over 2. However, since I'm going down, I'd say that's negative root 2 over 2. Okay? So we know that. We can throw 30, 60, 90 triangles just down in any location. We can see what is created. We also remember locations of radians. We'd say, okay, 2 pi over 3 is a pi over 3 less than 3 pi over 3. That's going to be right here. What's created? What angle is created between 2 pi over 3 and the x-axis? 60 degrees. This angle right here is 60 degrees. Okay. Well, that means if I throw a line down, that's a 30, 60, 90 triangle, where we have a longer side and a shorter side. If I go to 7 pi over 4, I know 8 pi over 4 is right here. That's 2 pi. I subtract the pi over 4, I go right here. This must be 7 pi over 4. What angle is created with the x-axis if I have a pi over 4? Half of 90, 45. This would be a 45 angle right here. Well, I could throw a line down and I got my root 2 over 2 lengths. If I look at 7 pi over 6, I know where 6 pi over 6 is. I add a pi over 6. That must be right here. What angle is created if I have a pi over 6? 30. So this angle right here is 30. And if I threw a line here, I could see I got a 30, 60, 90 triangle. Okay. We also know how to use SOHCAHTOA. Throw this in. And if I have a 30, 60, 90 triangle with side lengths like this, and I have this angle here, and I ask you, what is the sine of that angle? Sine is opposite over hypotenuse, right? What's opposite the angle? Discuss with your neighbors. What is the sine of this angle if I have side lengths of this right triangle like this? What is it? Discuss. What's the sine of the angle? Right. Square root of 3 over 2 over 1. What is square root of 3 over 2 divided by 1? It's just the square root of 3 over 2. If I ask you, what is the cosine of the angle? What would you say? One half over 1. 1/2. Right? Well, if I told you that was 60 degrees, you'd have the same answers, right? If this was 60 degrees, you'd be able to find that answer and it's correct, right? We're good with that? Like sine of 60 is the same answer. Well, what if I told you 60 degrees is the same as pi over 3? You'd be able to tell me that the sine of pi over 3 was root 3 over 2. Okay. So if I asked you, what is the sine of pi over 6? You will be able to figure out the answer pretty easily. Because first, you know where the angle is located. Discuss with your neighbors, where's pi over 6? What angle is created at pi over 6? Okay, let's think about that. Discuss with your neighbors, this is important. Where's pi over 6? First one, right here. You say this is pi over 6. Okay, sure. That's the distance. We could say that angle is pi over 6, but whatever. What angle measurement is created right here? 30. Okay. If I throw a line going straight down, I create a right triangle, a 30, 60, 90 triangle with a hypotenuse of 1. Label the side lengths of that 30, 60, 90 triangle. I can see I have a longer side and a shorter side. Label the side lengths. Right? The longer side is root 3 over 2. The shorter side is 1/2. If I just said this is theta, what's the sine of theta? Okay, well, opposite over hypotenuse, right? Opposite is 1/2. The hypotenuse is 1. You're going to say the sine of pi over 6 is what? 1/2. Because you could say this angle is the same as pi over 6. Opposite that angle, divided by hypotenuse, SOHCAHTOA, sine of pi over 6, opposite is 1/2. Okay? What's the cosine of pi over 6? Cosine is the ka, adjacent over hypotenuse. If I'm looking at this angle right here, what's the adjacent side to that angle? Square root of 3 over 2. What's the hypotenuse? Still 1. Cosine of pi over 6 is root 3 over 2. Okay. Tell your neighbor what the sine of pi over 4 is. I know where pi over 4 is. Pi over 4 is right here, 45 degrees. There's pi over 4. 45 degrees, right? Okay, so that's 45 degrees. I can throw a triangle down, and I know the side lengths of a 45, 45, 90 triangle when the hypotenuse is 1. What are the side lengths? Root 2 over 2, root 2 over 2. If I said we're talking about this angle here that is created between my angle and the x-axis, which is what we've been talking about, and we know sine, so, is opposite over hypotenuse, what's the opposite side length? Root 2 over 2. Opposite over hypotenuse. Okay, find the tangent of pi over 3. You can do it. Go. Figure it out. I know where pi over 3 is. I know I can create a right triangle that's a 30, 60, 90 triangle because I know pi over 3 creates a 60-degree angle. Okay, so I know pi over 3 creates a 60-degree angle. I know I can create a triangle where this is 60 degrees. That means the longer side is this, and the shorter side is this. Tangent, opposite over adjacent. TOA, right? Well, if we're talking about this angle, the opposite, root 3 over 2. The adjacent, 1/2. Dividing by a fraction is the same as multiplying by a reciprocal. Root 3 over 2 times 2 over 1 is just root 3. Now, what's great about a unit circle and triangles inside a unit circle when using SOHCAHTOA, H is always consistent. What is H? What is the hypotenuse of all of these right triangles that I can draw? 1. No matter where I draw this right triangle, where I just drop the angle down to the x-axis, the hypotenuse is always 1. So, O is always going to be opposite. O is always going to be the vertical distance. The vertical side length. Stop looking over there. Adjacent will always be the horizontal distance or the horizontal side. Therefore, sine, which is always opposite over hypotenuse, will always be the vertical distance over 1. Or the vertical distance. We'll call it the y distance. Cosine of an angle is always going to be the adjacent side over the hypotenuse, which always ends up being the horizontal distance over 1, or just the horizontal distance, or the x distance. Tangent does not use an h, but opposite over adjacent, vertical over horizontal. The y distance over the x distance. Now, if I look at obtuse angles, like the sine of 2 pi over 3, 2 pi over 3 is 1 pi over 3 away from 3 pi over 3. It's right here. And if you think about it, 2 pi over 3 is an obtuse angle. It goes all the way from 0 all the way over here. But turns out, I'm not going to get into the proof of this, that if we look at this angle here, which is created between the x-axis and 2 pi over 3, it's going to be the same value. The acute angle that's made between the x-axis and the angle. And if I ask you, okay, a pi over 3, what angle is created at a pi over 3? Everybody say it. What angle is created at a pi over 3? 60 degrees. Okay, well, if this is 60 degrees and I threw a 30, 60, 90 triangle, this is the longer side, this is the shorter side, right? However, I'm going to the left and up. So since I'm going to the left, I'm going to call that negative a half. If I ask you what the sine of this angle is, you'd say it's opposite over hypotenuse. Well, hypotenuse is always 1. Opposite this angle is the longer side of my 30, 60, 90 triangle. If I ask you what the cosine of 2 pi over 3 is, you would say it's negative a half. Okay, ready? Here's how we do it. And you're going to get to the point where you can do this in your brain. Okay, cosine 4 pi over 3. First thing I'm going to do, find 4 pi over 3. I know where 3 pi over 3 is. Add a pi over 3. I'm here. I'm here. I know what angle is created at a pi over 3. What angle is created at a pi over 3? 60 degrees. I'm thinking of a tall 30, 60, 90 triangle where my longer side is the vertical side. My shorter side is the horizontal side. I'm thinking about how I travel to get to that angle. I go to the left and I go down because I'm in the third quadrant. I'm thinking cosine is the adjacent to this angle created in my triangle. I'm always looking at this angle that's created between the x-axis and my angle. That angle, the adjacent side, is always the horizontal side. The horizontal side length is negative a half. The sine of 5 pi over 6. I know where 5 pi over 6 is. It's 1 pi over 6 away from 6 pi over 6. It's right here. What angle is created with a pi over 6? What angle is created with a pi over 6? 30. So if I'm thinking this is 30 degrees, I'm thinking I have a shorter 30, 60, 90 triangle, where the vertical side is the shorter side, the horizontal side is the longer side. Hold on. Wait till the bell. I'm traveling to the left and up. Sine is the opposite, or what will always be the vertical. The vertical, in this case, is a half. I can do the same thing with pi over 4s. 5 pi over 4. 1 pi over 4 more than 4 pi over 4. It's right here. If I think about creating a 45, 45, 90 triangle, I know both side lengths are root 2 over 2. Cosine is the horizontal distance, the adjacent side to my angle. Since I'm going to the left, this is negative root 2 over 2. We're going to do a lot of these before our next quiz. Our next quiz is just going to be trig functions of angles. And you won't be able to use a calculator either, which is great. So you have to embrace learning this.